Hello, my name's William Valentine. I'm a researcher at the National Center for Global Medicine, and today I want to talk about special cells that grow and repair muscle. From the time we're born, we already have all of our muscle fibers. So how is it that one baby's muscles are going to grow so much that they'll become a person with really huge muscles, and another baby may grow up to become a person with small or skinny muscles? All of this muscle growth after we're born is due to a special type of cell called a satellite cell that does nothing but grow and support our muscles. Understanding about these cells is important for all of us, whether we want to grow big muscles so we can be strong, have healthy muscles so that we can feel good, or most importantly is for patients with muscle diseases where these cells are constantly repairing or trying to repair the damaged muscles. So today I want to talk about three things. How do satellite cells grow our muscles? How do satellite cells repair our muscles? And why understanding how satellite cells repair muscles will open doors to lead to new treatments for patients with muscle diseases. So how do satellite cells grow our muscles? Well, our muscles are composed of long, flexible fibers, and each fiber is formed before we're born from the fusion of hundreds or thousands of precursor cells. And then by the time we're born, we already have all of our muscle fibers, so that number doesn't change. So how is it that the muscles can grow? We can't grow new fibers, so each fiber has to grow bigger. And the way this is accomplished is that along each fiber are associated with it those special satellite cells. And when the fiber needs to grow, the satellite cells actually divide, so we have 2 or 3 times as many of them. And then half of those cells may fuse with the fiber. And just by fusing with the fiber actually grows bigger. And then the other cells are left over so that they can remain there and then help the fiber grow in the future when it has a need to grow or be repaired. And so how do satellite cells repair our muscles? Well, our muscle is the most flexible tissue in the body. So each muscle fiber is elastic. It has to be able to expand and contract quickly so that it can move our bodies. But when the muscle is damaged, if there's trauma, the membrane of the muscle fiber may actually become damaged, and in that case it may become leaky, which allows things outside of the cell that normally don't enter the cell to leak in, and the inside contents of the cell may leak out. And this is very toxic to the cell, and if the leakiness isn't resolved, this fiber can actually die. But of course, the body doesn't want the fiber to die because we cannot grow new fibers. So it's the job of the satellite cell in that situation to actually, that they may replicate first, but then to actually fuse with the damaged fiber. And the satellite cell's membrane fuses with the fiber's membrane, so it may actually patch the leaky spot. And then the satellite cell also contains its own proteins and cellular machineries that when they enter inside of the fiber, those may actually function to repair the membrane from the inside. So how does this relate to patients with muscle diseases? Well, for patients with Duchenne's muscular dystrophy, which is the most common and severe muscular dystrophy, their fibers are all lacking a special protein, which is it's a structural protein that connects the inside of the fiber, of the muscle fiber, to the outside, which allows the muscle fiber to transmit force to the body and also gives structural integrity to the muscle fiber. So in these patients that are lacking this protein, the fibers are actually, because they lack a structural component, they're actually fragile, they're easily damaged and their membranes are easily to become leaky. And so in these patients, the satellite cells are actually working overtime. So when the disease starts, the satellite cells are actually constantly repairing the membranes. So the patients may not realize that they have this condition for several years. But at some point, the rate of damage to the muscle is too great and the satellite cells become exhausted. So in this case, then some of the fibers actually die, and this leads to the muscle wasting, and eventually those patients have to use wheelchairs even in their early teens. So when we understand about how the satellite cells naturally repair our muscle fibers, when we understand this process, we can think about new kinds of medicines that we can develop to treat patients with muscular dystrophies. So I thank you for your attention today, and I hope you'll learn more. You'll be interested to learn more about satellite cells in the future. Thank you.